Hello, one and all. Once again, welcome to Brainstorm X. Here we are with the second episode of What Brought Changes to the World. So, you guys probably clicked this video because of Cyclops. Well, today we will find out who invented the light amplification by stimulated emission of radiation. We know it as laser. So did Cyclops bring laser to the world?
No!
Was it Odin, the god and father of Thor, who amplified lightning into laser? We don't know why, but they couldn't. This wasn't how laser was created. Let's go back to the 1960s to find out the true origin of laser.
So, in 1970, Albert Einstein established the theoretical foundation for the laser and the maser in the paper Zur Quantentheorie der Strahlung on the quantum theory of radiation. On May 16, 1960, Theodore H. Maiman operated the first functioning laser at Hughes Research Laboratories. Maiman's functional laser used a flash lamp pumped synthetic ruby crystal to produce red laser light at 694 nanometer wavelength. Let us now find out what is the basic functioning of laser. Let us consider a hydrogen atom, but first we will stop the electron for only the sake of education. This is the electron, this is the nucleus. Electrons have different energy levels. This one is in its ground state, denoted by what you can see. Well, we will now take other energy levels such as E1 and E2. If we supply energy from outside as a photon, which is the difference between E1 and E0, it will force the electron to move from E0 to E1. This is called as the excited state of the electron, but it would come back from E1 to E0 soon, releasing a photon of energy. This is spontaneous emission. But if you remember correctly, in the full form of laser, we had stimulated emission. So let's find out what stimulated emission is. So now we have two atoms of hydrogen. Both have their electrons in excited state. When one of the atoms of hydrogen's electron comes down from E1 to E0 randomly, it will release a photon of energy of a specific frequency, which can interact with an excited atomic electron of the other atom, causing it to drop to a lower energy level. The liberated energy transfers to the electromagnetic field, creating a new photon with a phase, frequency, polarization and direction of travel that are all identical to the photons of the incident wave. This is in contrast to spontaneous emission, which occurs at random intervals without regard to the ambient electromagnetic field. Now, if we take a lot of atoms in a particular medium and surround them with two mirrors, this and this, the second mirror having a slight gap in between of both its mirror elements. All the atoms here are in excited state due to external supplied energy. On a random basis, the excited electron of a particular atom will come down from a higher to a lower energy level, which is, for example, E1 to E0. This will cause a photon to be released, which could then interact with any neighboring atom's electron, which would further cause the release of photons. The photons will be released due to the electrons being forcefully pushed from a higher to a lower energy level. Multiple simultaneous emissions will happen at the same time, which will create a chain reaction and subsequently a photon avalanche. Many photons will then reflect through mirrors and then finally find their way through the gap between the mirrors as laser.